This video is a part of series in which I am developing natural numbers from scratch, and by scratch I mean developing it from 5 basic axioms. So far we have developed the system of counting. In the last video we also developed the definition of addition. But because the theme of these series is to build mathematics from its logical foundations and not taking anything for granted in the way, so I've assumed that you don't know what addition actually means. So we proved that the operation stating that x plus y was a number, it gives you a number which satisfies these two properties. But I did not give you the intuition. In this video we will develop the intuition behind addition, what it actually entails, and to do that we'll have to apply it to a real world scenario. By real I mean physical world. Real in mathematics means different things, in philosophy as well. Well, suppose you have these many cows and these many goats, and with the system we have developed so far you can easily enumerate them. I am sure that you'd be expert in it by now. We would enumerate them separately, and we will do it like this. So what would I mean if I write that x double prime plus x prime? What would it entail? What would it mean? Intuitively it would mean that you can either increment it, this number, these many times. So if it were x and this were y, and if I wrote this, you could write that increment x y times. So suppose that I would enumerate them. So adding it would mean that I'm enumerating them, I'm extending it, incrementing it 2 times. Here increment and succession would mean the same thing. See, this is the concept of succession that we have developed in that we have taken from the axioms, and we are intuitively defining addition in terms of that succession. The second thing that you can think of is putting or combining x and y together. And let me demonstrate what I mean by this. Now suppose we can enumerate them using these pebbles. We can use different colored pebbles for this, for cows, and different colored pebbles for goats. So combining them would mean that we are arranging these pebbles in tandem, in series like this. So here we can write that x double prime plus x prime would be this. So you've got the intuition behind it. Now suppose we develop a number system, the one we have in English, where we call it 1, this we call 2, and then 3, and then 4, and then 5. What would it mean when we say this? We can intuitively see that 2 by 2 we mean these 2 pebbles, and then these 3 pebbles. And then if we combine them, if we simply put them together, these 3 and these 2, suppose these were pebbles, this would be 5. So we can see how addition actually works. And if we extend this a little further, there are some properties that we can see that it obeys and that it has. And what are those properties going to be? Can we write I think we can write it. How? Let's suppose it to be x to be these many pebbles and y to be these many pebbles. Then writing it in this way wouldn't change anything, would it? So intuitively we can see that x plus y is equal to y plus x. This is one of the property. What other property we could see that this definition of addition would obey? Let's suppose we write this. Where z is another number, another natural number. Can we write it like this? Let's see if we can do it. Now suppose our x and y are the same pebbles. We can write x and y like this. And let z to be this. So can we enumerate the same pebbles in different order? Can we write it like this? I think we can. So this gives us these two new properties. And another thing that we can say about natural numbers is this simple thing. Because we have started our natural numbers with 1, we can say that this can never be the case that x plus y is equal to y. This can never be the case. And intuitively we can say that we are going to x or y could be at least 1. It could be at least 1 pebble. And we can see that intuitively that this property also holds. But this is the intuitive definition, but this is the intuitive demonstration of these properties. And now we are going to prove them in the next video. But before we go on to the next video and proving these properties, I want you to note an important thing, and this thing is that in mathematics and in philosophy, explanation is not always the proof, is not necessarily the proof. Explanation is not equal to the proof. And for completeness sake, I would rather add intuitive explanation, and I'm going to add not necessarily a proof, because explanation in the philosophy of science means a completely different thing. So this is the take home message. Now we will get to proving these properties.